If you're in any algebra class or any class that uses algebra, you will definitely be solving linear equations. And I'm going to show you a 5-step process that will solve any linear equation you'll ever run into. I got the steps listed out here, which I know you can't read, but in the description you'll find a link to a PDF file, which is these 5 steps. And then if you look at that while you're watching the video, I'm just going to walk you through these steps and see how these steps can solve any of these equations. So just to make sure we're talking about the same thing, let's say we just start off with an equation that we would not need to use algebra to solve, because it's kind of a very simple equation. We can see the goal when we solve an equation is we want to figure out what this variable is. In this case, we know if x equals 2, then this would be true. So an equation is just a statement that this expression over here equals or is the same as this expression over here, and then we want to find the variable that will make this true. Linear equations are just equations that if you were to graph them, they would look like a straight line. But we're not graphing them, we just want to solve them. So for us to recognize a linear equation, it will be something like this, where the variable is raised to the first power. So linear equations will have x's, they may have a y, but what they won't have x squared, they won't have the square root of x or x cubed or anything like this. Linear equations will have just the variable to the first power. So to see how this works, I'm just going to look at an equation. 3x minus 8 equals 7. And what we want to do, we want to figure out what value can I plug in here for x to make this true. So in other words, if I plug in some number here, multiply it by 3, and then subtract 8, I get a 7. So to solve this, I'm just going to go right through the steps. These steps work on every linear equation. Of course, it's not the only way to go, but if you just want a step-by-step methodical approach that works on all of them, this may be what you're looking for. So step 1, it says distribute if necessary. Well, that's not necessary here. That's referring to if maybe we had something like this. Then we could distribute this 2, right? We could multiply it through here. Get 2 times x, which is 2x. 2 times negative 1, which is minus 2, equals 10. But we don't have that here. So step 1, we're all done with step 1. Step 2 says eliminate any fractions. Again, like in step 1, we don't have any fractions here, so we're done with step 2. Step 3 says get all variable terms on one side of the equation. Well, a variable term is just one of the terms that has a variable with it. And these terms are the little pieces of the equation. So terms are separated by pluses, minuses, equal signs. So in this case, the only variable term we've got is this 3x. And it's already on the left side of this equation. So step 3 says get all variable terms on one side of the equation. Already done. It doesn't matter if we put them on the left side or the right side, just says one side. But we've got our equation here. The only variable term is on the left side. So step 3 is already done. Step 4 says get all numbers on the other side of the equation. So numbers meaning non-variable terms. So we've got 2 numbers here. We already said the variables are going to be on the left side of this equation. So this negative 8, we need to get rid of it. Step 4 says to get all numbers on the other side of the equation. And it says do this by adding to negative numbers and subtracting from positive numbers. So basically, if we've got a negative 8 here, what we want to do is go plus 8. I'm going to set it up just like I'm doing an addition problem, right? Just like if you're in elementary school and we go 5 plus 1, right? It looks like an addition problem. See how this looks like that too? And the more you can make it look like something like that, the easier it is to just go through the process without making a mistake. One big thing though about equations is these are balanced. So I can add 8 over here as long as I also add 8 over here. Whatever I do to one side, I do exactly the same to the other side. So think of it like, think if you were babysitting a couple kids. they're really competitive. Maybe they're twin brothers, they're super competitive with one another. What if you just give one of them an ice cream cone and say, okay, go play? Probably gonna not end well, right? Just like that with equations. Whatever I do to one side, I do exactly the same to the other, always. And that's how we keep this thing always balanced. And then I just go through and I subtract. So I have this 3x minus 8 plus 8. Well, negative 8 plus 8, they cancel each other. We purposely did that. We want to get rid of that negative 8. So on the left side of the equation, all I've got left is 3x. The equal sign comes down. And then 7 plus 8 is 15. We're always going to have an equation. Right to the end, even when I get our answer, it'll be x equals some number. It'll still be an equation. So this equal sign has to be here every step of the way. So now step 4 is done. We've got all numbers on the other side of the equation. Right? I've got all the variable terms here on the left. We've got all the number terms on the right. Step 5 says divide if necessary to isolate the variable. Well, we do want to isolate the variable. We want it to have x all by itself. This x has been multiplied by 3. So we want to think of opposites. Just like we did here, we had negative 8, the opposite, positive 8. Multiply by 3, the opposite, divide by 3. And it says that, it says divide if necessary to isolate the variable. It is necessary. I need to divide this expression by 3. I'm going to make it look like a division. I'm putting a fraction bar, right? I'm dividing by 3. Just like if I had 10 divided by 5. That fraction bar can be read as divided by. 10/5 is the same as 10 divided by 5. It's 2. So I'm setting this up to look like I'm dividing, but whatever I do here, I have to do exactly the same thing here. So I divide this by 3. And now, 3 times x divided by 3, these will cancel, right? Like if I multiply something by 3 and then immediately divide it by 3, these undo each other. So what we end up with is x equals 15 divided by 3, which is 5. So x equals 5 is our answer. And we could always check it. If we wanted to check, we could just plug in 5 back in here and see if it works. So let's just check just to see. I'm going to see, okay, if I'm saying x equals 5. So if I plug in a 5 for x, will this work? Well, instead of 3 times x, I'll have 3 times 5 minus 8 equals 7. Let's see if it works. So 3 times 5 is 15 minus 8 equals 7. 15 minus 8 is 7 equals 7. So it works. So we know that our answer is correct. All right, so there's our first problem. And in this video, I think I'll do like 5 problems, and then maybe in other videos we'll do more. We'll start with easier ones, and we'll work our way up. So the second problem is going to be very similar. 2x plus 5 equals 13. So, go ahead and just think about what you do first. Maybe just pause the video even and think of your first step. Then come on back. Okay, so hopefully you press pause. There's only one way to get good at solving equations. You have to practice solving equations. It's the only way to do it. So basically what we want to do first, if we think of the same list, step 1 and step 2, again, we don't need, because step 1 says distribute if necessary. There's nothing to distribute. Step 2, eliminate any fractions. There's no fractions. Step 3, get all variable terms on one side of the equation. Again, it's already done, right? Here's the divider, the equal sign. On the left is our only variable term, so step 3 is done. Step 4, get all numbers on the other side of the equation. Okay, and it says, do this by adding to negative numbers and subtracting from positive numbers. Plus 5. Always think opposites. Yes, opposite of plus 5, minus 5. I want to get rid of that 5, but I'm trying to get x by itself. There's a couple things keeping this x from being by itself. There's a plus 5 and there's a 2 being multiplied. But I always want to take care of the adding and subtract first. Step 5 says divide. Step 5 is divide purposely, we always want to divide last. So add and subtract things first. Just this list, if you just go by this list and get used to this, it will never lead you astray. It'll work every time. So step 4 says get all numbers on the other side of the equation. So I'm going to subtract 5. Now remember, everything I do, I have to do twice, right? Because basically whatever I do to one side of the equation, I do the same to the other side. And I'm also setting it up so it looks like I'm subtracting 5. Sometimes students just want to rush through this, and sometimes if you can make yourself just be slow and methodical, you will eliminate a lot of common mistakes. And I wasn't always teaching, I worked in engineering before this, and I can tell you that slow and correct is way better than fast and wrong. So slow and methodical, especially when you're first starting. Maybe it takes an extra second or two to write it like this. But by doing this, you're going to eliminate a lot of easy mistakes that come up from going too quickly or from just not paying attention to the little details. So then from here, plus 5 minus 5, those cancel. 13 take away 5 is 8. Okay, so step 4 is done. We got all the variables on the left, all the numbers on the right. Then step 5, divide if necessary to isolate the variable. So I'm going to go ahead and it says here divide by exactly what is in front of the variable, including the sign. So in this case, there's a 2 here. I want to, this x has been multiplied by 2. I want to undo that. I want to get 2 by itself, or get x by itself and multiplied by 2. The opposite of that would be divide by 2. I want to get rid of that 2. And of course, whatever I do over here, I have to do the same thing over here. So again, that cancels. You get x equals 8 over 2, which is 4. And if you wanted to check, you could go ahead and plug in a 4 here, and it should work out. Okay, so those first two problems are pretty similar. I'm going to try something a little different. Problem number 3. We'll finally be able to do step 1. So problem number 3 starts off like 5 times x minus 2 equals 2x plus 9. Okay. Once again, as long as you can follow directions, you can solve any linear equation. It's like following a map. Just read through the steps, do what the steps say, and you'll get an answer every time. You'll get the correct answer, as long as you're careful, every time. So step 1, distribute if necessary. Well, this time it is necessary. I do have to distribute because remember this 5 in front of this parenthesis really means what? Multiply, right? It means multiply. So I need to distribute this 5 through. I need to multiply it through this expression. And you just go one at a time. 5 times x is 5x. 5 times negative 2 is negative 10, right? Positive times negative is negative. Equals 2x plus 9. So step 1 is done. Step 2, eliminate any fractions. No fractions here, so go on to step 3. Step 3 says get all variable terms on one side of the equation. Well, this time we've got 2 variable terms, right? Here's the equal sign. I've got 5x on the left, 2x on the right. We want to get them on the same side. It doesn't matter which side. A lot of times you'll just pick based on if there's going to be a negative introduced, or sometimes it's just more convenient to have the x on the left. So a lot of times we'll just put them on the left, but it doesn't matter which side. And it says do this by adding to negative terms and subtracting from positive terms. So I just need to decide. I either need to get rid of this 5x or get rid of 2x. So what do you guys think? 2x? Most people say 2x. Okay, let's get rid of 2x. Now most students would do that. I would also. I'm just going to get rid of the 2x just so I can have all the x's on the left side of the equal sign. Okay, so we subtract here. 5x minus 2x gives us 3x. Remember, these are like terms, right? They're like terms. This 10, negative 10 has nothing to do with this. These are like terms. They have to be exactly the same for us to subtract, right? So this negative 10 just drops down, the equal sign drops down, this is gone, and I'm left with a 9 over here. So after step 3, we have this. We've got all the variable terms on the left side, and now we need to get the number terms on the other side. So step 4 is to get all numbers on the other side of the equation. So we've got our variables on the left. Anything that's not a variable has to go, right? It's got to go on the right. So minus 10, I'm going to go plus 10, plus 10, which just looks like a 10. Remember, you notice that in red, I'm doing everything twice, right? Whatever I do to one side, exactly the same to the other side. That's going to cancel out, so you get 3x equals 19. So I've got all the variables on the left, all the numbers without variables, right? Numbers without variables on the right. Then step 5, divide if necessary to isolate the variable. It is necessary. We need to get this x by itself. It's being multiplied by 3. So what's the opposite of multiplying by 3? Dividing, right? We can't subtract here. Always think opposites. That x is being multiplied by 3. We want to do the opposite. We divide by 3. So I'll make a little division sign here. So then these 3's will cancel. So we'll get x equals 19 divided by 3. So it's an improper fraction from here. I mean, it's simplified all the way. Like, there's not a number that divides into both of these. But sometimes students don't like it with an improper fraction. So if you don't like it like that, just think, okay, it's really 19 divided by 3. Well, 3 times 6 is 18. So we could go 6, and then there'd be 1 left, right? 6 1/3. You could leave it like that. I mean, either one of these are okay, really. Remember, just a little practice to get back here. You multiply here, then add. 6 times 3 is 18, plus 1 is 19. Or for the decimal fans out there, I know a lot of you guys like decimals way more than fractions, I know. If you punch this in your calculator, you'll see 6.3 forever, right? So we can show that we put a little bar over the 3, just means the 3 repeats forever. Okay, so that one we got to use the distributed property. And let's look at another one with distributed property, a little messier, okay? I'm just going to show you that these steps work on all of these. So make one that's a little messier. So this is problem number 4. Maybe I'm going to erase this just so I can have a little bit more room up here. So problem number 4 says negative 3 times 2x plus 1 equals 2x plus 4 minus 7. Now you gotta admit, that's a good looking equation there, right? Pretty good looking equation. And it's got a lot of stuff happening. And you might even notice that there is something better than having one distributive property in a problem. That is, of course, having 2 of them in a problem. And we've got that here. So let's just go right down the steps. Doesn't matter what these look like. This 5 steps works on every single one of them. All of them. Doesn't matter. Step 1, distribute if necessary. We can actually do that twice here, right? We can do that twice. We've got a distributive property on each side of the equation. So I do this one. Remember, negative times positive. Negative times positive is negative, right? When you multiply, negative times positive is negative, so we get negative 6x. Negative times positive is negative. 3 times 1 is 3. Equal sign comes down. 2 times x is 2x. 2 times 4, positive times positive is positive, so we get plus 8 minus 7. Now here's something that we kind of always want to keep in mind, and that is we want to combine like terms whenever we can, when they're on the same side of the equal sign. So like these are not like terms here, I can't combine them. Negative 6x minus 2, they're not like terms, right? It's like, well, over here we do have like terms. Okay, over here we do have like terms. We got 8 minus 7. So this is kind of like a long way of talking or writing. Like, let's say you had $8 and then you spent $7, so you had $1 left. Let's say your friend says, hey, how much money do you have? You just say $1, right? You wouldn't say, well, I had $8, then I spent $7. Or you wouldn't say that, you say $1. Let's do that here too. Whenever we can combine like terms, when they're on the same side of the equal sign, we can simplify them, clean them up a little. So this is just kind of like a sloppy way of saying this right here. Minus 6x minus 3 equals 2x plus 1, right? 8 minus 7 is just 1. Isn't this better? Just a more condensed, more concise, right? So whenever you're solving these, we do always want to keep that in mind. If we've got things on the same side of the equal sign that we can combine, we want to combine them. Okay, so well, then we get here, you see every step, we've got an equation every step, but it's getting more simple looking, right? It's getting simplified. Step 2, eliminate any fractions. No fractions yet, but don't worry, the next problem will have fractions. No fractions here. Step 3, get all variable terms on one side of the equation. Well, once again, we've got variable terms on two sides of the equation, right here and here. So in this case, some students would actually add 6x just to avoid working with a negative. And you can. Look at what it says. It says get all variable terms on one side. It doesn't say which side. It really doesn't matter. So sometimes maybe you'll get an answer and you'll get something like 3 equals x. Well, that's the same as x equals 3, right? So it doesn't really matter which side you put the variable on. You might just get your answer looking like this if I put them all on the right. Okay, so it really doesn't matter. But I guess I'll just do the same thing as before. I'm going to subtract 2x from each side. So I'm going to put all the x's on the left, right? I'm going to all the x's on the left. Again, this is not the only way to do this, but this method works every time. So I'm just going to always just go by this step-by-step method. So over here I've got minus 6x minus 2x. Sometimes these are a little tricky with these negatives. I think it's easier to think of money. Let's say you are $6 in the hole. Your bank account's at -6. Never good, but let's just say it is. And then all of a sudden, you go through and you withdraw $2 more. Well, now where's your bank account going to be at? It's worse, right? Now it's at -8. Minus 6x minus 2x is going to be minus 8x. This minus 3 just drops down. The equal sign comes down here. 2x minus 2x is gone, and I get a plus 1. Right? Notice again, whatever you do to one side, it's the same to the other side. So then, step 4, get all numbers on the other side of the equation. So I put all the x's on the left. So all the numbers that don't have an x, they have to go on the right side. So this minus 3, I need to get rid of the minus 3. All to the opposite. If I have a -3, I want to add 3. Whatever I do to this side, I have to do to this side. So I add 3 over here. So this goes, and we get -8x equals 4. Right? And then what we want to do is divide by -8. Right? I mean, we're at step 5, divide if necessary to isolate the variable. So we want x by itself is being multiplied by a -8. So I divide by that exact same thing. I'm going to make a common mistake. See if you guys can spot it. Very common mistake. I know it's hard to even look at. Some of you are going to have to look away as soon as you see it. It's hard to look at that, isn't it? There's a mistake being made. I need to divide by exactly what's in front of it. If I divide by +8, I'm going to end up with a -1x, which is not what I want. I want x. So whatever this is, I have to divide by exactly that. So I need the negative. Then these will cancel out, and I'll get x equals, I'm going to write it up here. So get x equals 4 divided by -8. So 4 over 8. It's a negative. It doesn't matter where we put the negative sign. We could put it with a 4 in front of the whole fraction or with the 8, it doesn't matter. But 4 over 8 You guys would never leave an answer like that, right? 4 over 8. We always want to reduce these, because I don't know if you know this, but when you don't reduce your fractions, it's very bad. What happens is, first of all, you start drinking more, and then drugs, skipping class, dropping out of college, and a life of crime. We don't even want to start. So always simplify. We can divide both of these by 4, and we'll get negative 1 over 2. Okay, I made up all those statistics about not simplifying. I'm just trying to keep you guys awake while you're watching my videos with my bad jokes. So generally though, you do want to simplify. 4 over negative 8 is just better to write it as 1/2. Makes more sense, right? If you're talking about a half of something, you don't want to say 4/8 of something. So, okay, so there is problem number 4, our last problem, which I just mentioned will have a fraction. You guys have been very patient waiting for one with a fraction, so here's a problem with a fraction. This will be our last problem. Problem number 5 says 7/3 x plus 4 equals 3x, or equals, let's go with equals x minus 2. Okay, we've got this equation. We go through the steps. Step 1, distribute if necessary. There's nothing to distribute here. But then step 2 says eliminate any fractions. We've got a fraction. We want to get rid of that fraction. So what we can do, it says here for our step, if there's one fraction, which we've got just one fraction, it says multiply both sides of the equation by the denominator. So we want to multiply by this 3. Whatever is in the denominator, we're going to multiply by that to eliminate the fraction, to eliminate this fraction. But I can't just multiply this by 3. I need to multiply everything by 3. But just to convince you that that's okay, and ask you a real little baby equation here. If we're going to solve this, we can see the solution is 3, right? The solution is 3. Just want to convince you that we can multiply each side of the equation and not change that. So let's say I multiply everything here by 4. Let's say, just for instance, multiply everything by 4. Multiply this left side by 4, which means I have to distribute the 4 through. 4x plus 8 equals 20. Remember, the solution to this one is 3. Is it still 3 here? It is, right? The solution is still 3. If I plug a 3 here, and I get 4 times 3 is 12, plus 8 is 20. So when I multiply each side by 4, it didn't change the solution. It's still the same. That's what we're going to use up here. So we're going to have to multiply both sides of this equation by 3. That's what it says to get rid of this fraction. Because I can't just multiply this by 3 because I changed the whole question. But if I multiply this side of the equation and that side of the equation by 3, then I'm okay. It won't change the answer. The question will look different, but it'll be equivalent to this question. So you don't typically want to write this, but I'm just going to write this now just to explain what we're doing. So when I multiply both sides by 3, it's sort of like I'm distributing this 3 through both sides. Again, you typically don't write this, but just to make sure, I can do anything I want to one side as long as I do the same to the other side, right? So if I multiply this by 3, this will distribute through here, this distributes through here. So essentially, every term gets multiplied by 3. Keep that in mind here. If I'm going to multiply this by 3 to get rid of that, every term gets multiplied by 3, right? That is equivalent to multiplying each side by 3. So what we'll do then is I'm just going to multiply each side, each term by 3. I'm going to multiply this term here by 3. This one I'm going to purposely write it like this, 3 over 1, so we can see that it cancels. But then I need to multiply this by 3, that by 3, and that by 3. Each side's getting multiplied by 3. So this one, we purposely chose the 3 to get rid of that. So that cancels, so I just get 7x. Plus 4 times 3 is 12. x times 3 is 3x, and then negative 2 times 3 is minus 6. Now this part here, if you're not really comfortable with that canceling, just think if you multiply fractions, you go straight across. 3 times 7 is 21, 1 times 3 is 3, so you get 21 over 3, which is still 7. So once you do step 2, all the fractions should go away, all of them. So if there's any fractions left, something didn't go right. Step 2 will eliminate all the fractions every time. And now we go to step 3. From here it's a problem like we've seen before. Get all variable terms on one side of the equation. So the x's here, I'm going to again put the x's on the left. Also remember, you don't have to. You can put them on the right side of the equation also, it doesn't matter. But I'm going to subtract 3x here and subtract 3x here. So again, that will cancel. I get 7x minus 3x, which is 4x, plus 12. That comes down. The equal sign is here, and I get negative 6. So step 3 is done. Step 4 says I get all numbers on the other side. So all the variables are on the left. I need to get rid of any numbers, so I need to get this 12 on the other side. This is a plus 12. What's the opposite of plus 12? Minus 12. I think you've got it. Negative 12. And then that cancels, we get 4x equals. Okay, this is the ones that give us trouble sometimes. You can think of money. $6 in debt. Your bank account is at negative 6, but you go through the drive-thru and withdraw another 12. Now what would it be at? Negative 18, right? Okay, so step 4 is done. Step 5, divide if necessary to isolate the variable. Okay, we want to get x by itself. It's being multiplied by 4, so we divide by 4. And that will give us x equals negative 18 over 4. But I know, after that dire warning from last time, you guys would never leave it like that, right? They're both even, so you can divide them both by 2 and get negative 9 halves, or for the decimal fans, negative 4.5. Okay, so remember really the only way to get better at these is to practice. So do a lot of practicing with these.